All right, now we get to surface water, you know, rivers, lakes, reservoirs, things like that. Um, so, infiltration of the water is controlled by, so it's the intensity and the duration of precipitation. So, like, if it rains for a long, long time, you got a flood. Um, the prior wetness conditions of the soil, the type of soil, the slope of the land, and of course the nature of the vegetation. Right, that's actually really important. Um, all right, so running water shapes the Earth's surface in two opposite ways. It's kind of slightly ironic. It carves out the landscape. All right, that just like we learned about with the sinkholes and so forth. Um, but it also deposits sediments. Right, it carries the sediment. It carries the calmer water will carry smaller sediments because it just doesn't have as much energy, and then the more turbulent water will carry larger pieces of sediment. So keep that in mind. All right, so stream flow geometry. All right, so we'll talk about how when a stream is flowing along. Factors that determine the velocity is, of course, the gradient. Is there a large rise over run? Basically a really large slope. Um, the discharge, the volume of water that's moving past a given point in a given amount of time, the channel geometric characteristics, right? The shape of it. So if it's more of like a bowl shape versus very very deep channel, the water flows at a certain way, a certain rate. We're going to see that in just a second, as opposed to shallow water. Right. All right. So let's see stream geometry. The average stream speed is the discharge over the cross sectional area. Okay. So stream speed is usually not constant along the length of the stream. As the stream moves downslope, the gradient decreases and the channel widens, and of course, everything slows down, including the flow of the water. Discharge usually increases as tributaries and adds water. Okay. All right. So stream speed varies within a channel. It's slower along the stream bed. So if you have, let's see, does it? So in the middle of a river, let's say, the speed is greater in the middle than it is at the sides. At the sides, or the deepest part, it's always the speed of the stream is a little bit greater because there's friction. The fluid is touching the sides of the riverbed, and that causes friction. All right, so the friction will, of course, will slow things down. A straight channel will give you the largest speed. The curved channel, so the one like this, the speed it'll slow down here along these straight areas, and where it's turning, where the water, where the flow is turning, like right here, the outer part of the turn is the fastest. So right here it would be fastest, and right here it would be fastest. Okay, so in the curving channel, the maximum flow speed is in the outside of each bend. So right along here and right along here, just like I said. All right, the drainage basins and networks. Okay, so the land area contributes water to the stream is called the drainage basin. And sometimes you're driving along on the interstate, and they'll mention what it'll say the name of some river and what it's bait. Like for example, the one near Charlotte. I lived near Charlotte for a long time. It's called the Catawba Basin, and they talk about that. So any streams or lakes and so forth that are right around that area, they contribute to the Catawba River. All right. Anyhow, the drainage bases are separated by drainage divides. The largest divides are the continental divides. Okay, so the main continental divide is right here through Colorado, and everything to the east of this flows towards the Atlantic. Everything to the west flows towards the Pacific. So that's why it's called the continental divide. Of course, the Mississippi flows down from Minnesota. The Ohio flows down from Ohio and joins the Mississippi, and there's other tributaries. The Arkansas River, the Red River, join the Mississippi. The Mississippi is incredible. If you never cross the Mississippi, you're amazed when you get on the bridge just how long the bridge is and how long it takes to cross that thing. Anyhow, the flowing surface water sculpts and shapes the Earth's surface. Erosion, you've got erosive sculpting, that goes on. Certainly with the Mississippi, that's been going on for a very long time. And then there's, just like we talked about in chapter 20, there's deposition where it's depositing material that it's carrying, that the water is carrying along. Different sediments and things like that. Sometimes little small pebbles and things. If it's the more energetic the water is, the larger the particles that it can carry. And in fact, that's exactly what, as the water slows down, the larger particles, the larger sediments will be deposited first, and then ultimately the smallest ones. All right, so let's see, stream flow, two types of flows. All right, so this is actually important. There's a thing called laminar flow and turbulent flow. This works just as well for water as it does for air. For example, if you have the wing of an airplane, you want laminar flow. You do not want turbulent flow. Turbulence is like if you're in the airplane and the plane just suddenly jumps up and down a little bit. Usually it's not too bad, but it can be kind of frightening. And so you don't want to be going through turbulent air. The pilots usually, change the height so that they get away from the turbulent atmosphere. Anyhow, let's talk about this as far as water goes. So when the water is these really relatively flat layers, that's called laminar flow. All right. So and then when the width of the river or whatever the heck it is, if that changes, and especially when it narrows, you're going to get this turbulent flow, like the water starts splashing about. I mean, that's for example, that's when you get into like rapids, right? The very fast rapids. People who like to do kayaking, they know all the different types of rapids. I think don't quote me on this, but I think there's like five different rapids. Like a level 5 is extremely difficult to go through. Anyhow, that's a different story. All right, so streams transport great amounts of sediment from one location to another. The laminar flow can lift and carry only the very smallest, right? Because that's the calm. The turbulent can carry much larger particles. That's the story here. And of course, as the turbulent turns into laminar flow, the larger particles will be deposited first. All right. This is something interesting that happens, and sometimes you can see rocks that looks like there's a hole in it, and that's because of what's called abrasion. And so this abrasion is when sediments that are different from this rock that pass through. Let's say they're really sharp in some turbulent flow. As they pass through here, they can gouge a hole in these things. especially like if, let's say there was some giant flood and it was carrying all these little tiny rocks that were really sharp over a period of time, over an extended period of time, and you get these holes. Um, Hydraulic action, so that's the erosion and the movement of great quantities of sediment. Okay, so that's just an example. Chemical weathering. The stream water carries dissolved substances that chemically weather and erode the rocks. All right. So abrasion is when the little sediments, the little rocks and stuff that are carried with the water will actually dig a hole. All right. So stream erosion, loosely consolidated particles can lifted by abrasion and dissolution. Stronger currents lift particles more efficiently. Stronger currents have high energy, lift and transport much bigger particles. So that's the difference between turbulent and laminar flow. The work of the water streams and valleys and floodplains. One of the great examples of water passing, changing the surface. This is not a picture of it, but it would be like the Grand Canyon, right? Streams that have passed through mountains and literally, over the course of time, dug through the mountains, and that's like you see that in different places. Like for the Grand Canyon, it's of course the Colorado River. Over the course of millions of years. So fast, rapid moves and beautiful waterfalls are characteristics of these V-shaped mountain streams. Let's see, stream speeds play a role in erosion. So remember they speed up over here, so that there's going to be erosion that takes place, and this they call that a cut bank erosion. So the stream is faster here and it's faster here. And so it's going to take some of the land, some of the particles of the soil with the stream. Let's see. Meandering streams create wide beds of almost flat land, which is called a floodplain. When a flood occurs, the sediment is deposited in the floodplain. Large and coarse sediments create natural levees. So so sometimes it can trap the water, even during a flood. All right, so this is a delta. Probably the most famous one is the Mississippi Delta. A delta is where the flowing stream. So if you can talk about the Mississippi River. You could talk about the Mississippi River as a stream. It meets a standing body of water, like for example the Caribbean, and it slows down and it starts to dump incredible amounts of sediment. And by the way, that sediment is usually very rich in nutrients, and it's like you want that to grow crops and stuff like that. All right, the result is this fan-shaped deposit, and you get new land as well at the think about the area south of New Orleans. All right, and I wanted to show you one other thing. All right, this is actually from my astronomy class. I just wanted to show you something because since we're talking about river deltas, so take a look at this. So on the left-hand side, right? Over here, this is a delta on Mars. This, of course, onto the right is part of the Louisiana Delta, right? This is part of the reason we think that Mars, billions of years ago, about 4 billion years ago, had running water. We compare what's going on Earth with what's going on Mars in particular, and this helps us understand that this pattern, although it's not liquid, it was left by liquid, and so there was once running water on the surface of Mars. So that's the geology has helped us.